screen up?
Yep.
Okay. Hi everyone, good morning. So this is Abhilash from group 8. We stuck to the same group as we did last time for our standard presentation. So we with the team members Amrita, Parvinter and Sudhakar, because we could really work well together. And the reason why we went with this topic was because we needed to get some hands-on on the OAI core lab. Through our lab assignments, we did get some experience deploying or simulating different network scenario using NetSim, but we wanted some hands-on with the OAI core lab, so that's why we went with this topic. One sec, my slide is not good. Yeah. So agenda. So we have designed the agenda in such a way that we can take you through the thought process that we went through in finally arriving at the Capestone project objectives and ideas. So we will be talking about how we set up our own 5G core lab server in the cloud, how we then replicated the demo experiments to validate the lab setup that we have, then the progress that we made in these activities, the challenges that we faced, and the result of the experiments that were conducted so far, and finally the objectives and expectations of the Capstone project that we will be going to do. Good, so this progress snippet at a high level. So the first thing that we did to familiarize with the open-air interface, this 5G core and lab, was to set up our own lab in an AWS EC2 instance. The reason for it is like we will have some benefits, like first of all, the server is in cloud, so the setup can be shared with the team members. Secondly, it's a dedicated lab now for the team, so there is no access issue. And we will also understand how to install our very own 5G core lab using the guide that was shared with us. And being a cloud server, there is no resource constraints as such, so we can add more resource if we want to run the experiment dynamically, and it's more cost effective since we can tear it down after the project use case. So that's what we did first. Second thing was once we had the setup ready, we created our own Git branches inside this OAI core and OAI RAN module so that we can experiment independently. So we created our own branch, and in fact the team learned about Git essentials just for this purpose, and we did experiments that way. And to validate the lab setup and to get to know this folder structure and where each configuration files and all are present, we first we replicated the experiments that was demoed to us. So, and once we got to know that, then we extrapolated it a bit further by doing 2 more cases where we 2 UAs belonging to different DNNs and network slices we connected to the GNB and tried, and also we extended it to 3 UAs and did the IPUF test of and calculated the throughput in parallel. So yeah, this is just a snippet of the server that we have. We have a vCPU and 32 GB memory there, and this is the workspace that I was talking about with individual branches. And we have made this prompt a bit more user-friendly so that it will show which is the current branch that we are on, and if there is some modified files that we haven't committed yet, there would be an asterisk next to the file name so that whoever is logging in next can stash those changes before checking out their branch and doing their work. So yeah, these are the experiments that we have done so far. As I mentioned, GNB serving single UE, 2 UEs, and then DL throughput calculation, and GNB serving 3 UEs. The snippets and results of all these experiments we have kept to the end, actually, so that we can go through it in detail if time is there. So otherwise, when the slide deck is shared, you can go through it at your leisure, but it is there. So yeah, next is the challenges that we faced. So of course, while setting up the lab server, we did face issues, but it was well worth the effort. Now we have a dedicated lab. Secondly, we did find that sometimes the SMF doesn't assign the IP address to the UE. It would be shown as registered in the AMF logs, but IP address won't be assigned. So if you check if config, there won't be any AI10 UE listed. So exact reason for it we didn't find. We did try with changing the no kernel mode option while bringing up the UE, but still it didn't help. But the workaround that we found is that if you restart the core and try again, it works as does assign. So that's what we are doing now. The other challenge that we faced is that GNB, while serving more than one UE at random interval, it crashes with an error. So this I had mentioned earlier, and I have raised a ticket for the same. And the other issue that we found is that for a single UE, we are able to bring up that NR scope. But while doing multiple UE, we will be invoking that UE executable from inside a network namespace, right? From there, when we do it, you can't even bring up the UE instance because it is unable to display that NR scope. So we had to run it without the NR scope mode. So for that also, I had raised one ticket by sending an email. Last is we would like to have some guidance on interpreting this NR scope. So if you check this NR scope window that we have, it's not very clear how to read this NR scope much. I think this is the signal constellation that we have, but also we would like to have some guidance on this, and maybe whether we can edit it to display some other information as well. So if anyone knows it, you can let us know during the queries and guidance section of this presentation. Yeah, so these are the